This, I think, is the one that is the second most controversial. And this is the one where probably the most academics at Macquarie disagreed with me, and most of my industry colleagues all said, you're spot on correct. So this is one of those industry versus academia distinctions. If you are running some computation, you've got your machine learning model, you've fed some data in, and it's turned that into tokens, and then it's looked that up with the embedding, and then it's done some calculation of a whole bunch of multiplications of these matrices that we learn about. And you can sort of look at the whole memory of what's in memory at the moment. Gigabytes of stuff, values being calculated, the current, as we've added some extra words, what's the complete set of those? And what you could do, of values in memory, and what you could do is you could say, this is like a really high dimensional, real valued space that you would have perhaps stayed awake for if you did first year maths or something, which says, I could plot this. Can't plot it in 3 dimensions unless I only had 3 variables, but I've got billions of variables, so I need a billion dimensional space. And the next token that's going to come out is really a question of where are you in this billion dimensional space. If you're over in this tiny little corner over here, we're going to output the word elephant. If you're in this other spaces over here, we're going to output the word rhinoceros. And if you're in over another space over there, we'll output the word quantum physics or something. Whatever we're doing, all we're trying to do is make sure that the next token that comes out is the correct token. And we could do this in one of 2 ways. Either I could have a whole bunch of words in my prompt, all the text leading up to this, which of course is going to influence where all the calculations are, because these transformers are going to go, oh, I see the word safari, therefore the word elephant becomes much more likely. Or I see the word photonics, therefore the word quantum physics is it's not one word, but the phrase quantum physics is the most likely thing to come out. Prompting is doing that. Or the other thing you could do is you could do fine-tuning. If I had a whole bunch of trained data on what I wanted things to look like, then I could take the existing weights and update them. And what's the effect of that? That means this space for elephant shrinks because I'm training it on all this data that wants to output quantum stuff. And the spaces where the correct word is quantum get stretched and expanded. And I now have a new model that's really likely to output the word quantum rather than the word elephant. Either way, what we're doing is we're just sort of stretching and warping spaces, or we're trying to force the state of the system to jump to somewhere. In the past, this was a no-brainer. Fine-tuning was always more effective. Nowadays, everybody I know in industry says, yep, prompt. Just come up with a better prompt that'll take you much less time, and the results are much more effective than fine-tuning. Everybody in academia that I know says, no, fine-tuning is the only way you can really be sure of where you're going to end up. The academic answer is, that idea that prompting is as effective as fine-tuning, just anecdotal. Nobody's actually studied that comprehensively. So just because you and your industry colleagues think that that's the case doesn't necessarily mean it is. That could be just your biases. And the flip side of it is, maybe it is, but nobody knows for sure. So that's why we need to talk about both of them. So the summary is, like, how do you run these experiments over multiple years, given the whole industry changes in 3 years? And I think that's why this particular question is really controversial, because it's not good enough to say, on this problem, we found that prompting did better than fine-tuning, because the fine-tuning advocates will say, oh, of course, you didn't do this and you didn't do that. If you just trained it a little bit longer, that would have been fine. And if you said the other way around, the prompting people would say, oh, that's just a terrible prompt. Let me give you a better prompt that would get you there. So the projects that I've done over the last, say, 6 to 12 months, we've all found we iterated really fast on the prompt, and we got better results than any of the fine-tuning things we did. But that's all the industry stuff. In academia, we've seen paper after paper after paper talking about fine-tuning. So I'd love to have some really clear guidance on this, but I've got nothing other than, yeah, I think it's this way. Let's take the industry view of this, which is, it seems that prompting is better than fine-tuning. And so with my extremely elegant diagram here that I scratched out on a piece of paper and then scanned, what seems to be the case is that your best option is few-shot learning, which is, I've got some examples. So I say to the LLM, an example of a sales call is, I want to buy a ticket. An example of a support call is, I need to update my ticket. Now classify this call based on that prompt. And that's what I got you to do in assignment 1, those of you that have handed in assignment 1. That seems to be the best way of doing things. Question is, could we do better with fine-tuning? Let's just say for the sake of the argument it's not, and that fine-tuning is about equivalent to zero-shot. Zero-shot would be something where you just say, classify this call. Don't give much more context, or classify this call into sales or support, and it's just using its background knowledge. One thing everybody does agree on is that that's definitely better than going from scratch, because from scratch you won't have enough data. And the desperate attempt with green and yellow highlighters here is, notice that the green side, you can get there just with domain knowledge. The yellow side, you kind of need a GPU and you need some tech skills. Which means that over on the green side, there are a lot of people that can understand how to prompt something. On the yellow side, there's not as many people who know how to fine-tune or train a model from scratch. That's why you're in this course, so that you can learn how to do it and make lots of money from it. There's just something slightly disturbing about this. I realise it's kind of depressing in the middle of a unit to say it may be the case that these skills on the yellow side are not as valuable as the skills on the green side. Quickly switch courses and learn something else. In reality, it wouldn't play out like this, but we do have, that's going to have real weird implications for data science jobs and AI jobs. What it means is that you're probably going to find yourself doing a lot of prompt engineering and helping people with prompt engineering and studying, okay, this prompt and that prompt and that prompt has this problem, this problem, this problem. We've got this information from the domain experts. Now I'm going to figure out how to address all these issues by coming up with some super mega prompt to do stuff. And of course it can't get this information right, because in our few-shot learning we're doing this problem. We can't do few-shot learning the way we thought, because it's going to take up too many tokens and it's going to cost too much. And I think that's kind of the jobs that you'll move into next year or next semester, depending on your schedule. That would be my guess. One design principle from that is expose the prompt. If you've got some program, like your assignment 1, and you were deploying this, then you'd probably make sure that the owners of the system, whoever was going to be maintaining it long term, had some easy way of changing the prompt. So if you hard-coded the prompt for your intent classifier into code, maybe you wouldn't do that. Maybe you would go and look up a database to get the prompt, so that somebody could modify it just by editing a record in a database somewhere. And the reason for that is it often brings weird, unexpected benefits. You won't know the domain area as well as some expert there, and the expert might well say, oh, well, of course you've got to consider 17 different things that you wouldn't have thought of. Makes your prompt 10 times bigger, but it suddenly gives them the power to do all sorts of stuff. Of course, exposing the prompt brings security problems, like prompt injection. I think one of the really interesting new areas of development is not, I'm going to type in this prompt and get a response back, but I'm going to have these prompts which get run automatically when something happens. So one of my favourite programs at the moment is a thing called sweep.dev, where when you raise a GitHub issue, it has a whole series of prompts of what to do with that. Well, the first thing I'm going to do is read that issue and figure out what files are relevant. Then I'm going to figure out which functions in those are relevant. And so the first prompt is something like, based on this list of file names and this issue, what files is it talking about? Then it has another prompt, which is, here's the content of these files. What functions do you think you need to modify? Then the third prompt is, given this function code here and given this issue, what do you think you'd need to do to fix it? Here's the code. Given this code and that code, how would you patch them together? So what have we got? 4 different prompts being fired off in sequence. So there's a lot of interest in how do we get that sort of agentic behaviour of what would be a prompt that would let me feed into the next prompt. How can I prompt it? How can I meta prompt it? How can I get it so that the prompt to the next thing is useful to it? And how far can we go? How far ahead can we get it to plan? Stuff like that. But all of that, by the way, isn't chat. All that's completely asynchronous. I just create the issue and it goes off and does its thing. And yeah.